Hi there, this is Kevin Patton with a brief chat about a technique called running concept lists, which is a simple strategy to identify, connect, and apply core concepts of anatomy and physiology. Now, before we get into the main meat of it, when I first gave this presentation live in a face-to-face workshop at a HAPS annual conference, I joked that I could really cover all the essentials in 3 minutes, and in fact had already done so in the bus the morning that they took us to the site for the workshops. And that's true, but this is going to last a little bit longer than 3 minutes, actually quite a bit longer than 3 minutes, because even though it's a very simple idea and you can explain its essence in just a few minutes, there are really many layers of understanding it and many layers of thinking about how to apply it in a teaching or learning situation. So I'm going to emphasize that. And keep in mind that this is a strategy for students to use to learn. But of course, it's a strategy that we as teachers can introduce and maybe even help facilitate either in a large group or on a one-on-one basis when we're advising an individual students on how to be more successful in learning in general and anatomy and physiology in particular. So I'm going to start at the very beginning because, well, part of the goal is to not discover the basics in 3 minutes, but kind of really get to the heart of what's going on here. And so we have to kind of rewind to the very beginning of things, and that is, how do we know things in the first place? If we understand how we know things, how we learn things, then we're going to understand better this very simple technique of using concept lists. So I'm coming from the perspective of an idea of learning called, or a theory of learning called, Constructivism. Occasionally it's called Constructionism, but it's been around for a very long time and it's a very widely held idea. Although there are slightly different variations of this, it basically states, when you get right down to it, that we build our own knowledge. In other words, I don't give knowledge to my students. They have to build it. Now, what I can do is help them build it. I can give them the materials they need, the techniques they need to build it, and I can coach them along as they build it, but they really need to build it. I cannot give it to them. I cannot pour it into their brains. And we all know that, right? Now, another way of saying pretty much exactly the same thing, but it just sounds a little more scientific, I guess, is if we say, instead of we build our own knowledge, we could say we build our own conceptual framework. And that term conceptual framework is a term I use a lot because, well, that's just the way things work in my brain, and hopefully it'll be helpful to you too. So let's take a minute to look at that idea of what I mean by conceptual framework and how it's built. It's built by experiences. That's the whole idea behind constructivism, is that we have to experience something in order to bring it into our mind and put it into this conceptual framework. And that experience can be either active or passive. Now, there are a lot of people in constructivism who will say, well, it really only works if it's active. That is, if a student does a dissection, does an experiment, experiences something firsthand in a very active way. And that is certainly true. Learning can and does happen that way, and it's a very powerful way to learn. But students can also learn in a passive way. So if I tell them a story, they can learn from it. If I give them a set of facts to read, they can learn from that. They can learn from the so-called passive activities of listening, of reading, and so on. And that may or may not be as powerful as active learning, but it is a part of learning. With you watching this passively, listening to this passively, I hope that you're going to walk away having learned something from it, and you will have put that into your conceptual framework. You will have used that as a building material to build your own conceptual framework, that is, build your own knowledge. So with that in mind, let's dissect this term even further. And if you've listened to my podcast at all, you know that I love dissecting terms. So we're going to dissect this one. Taking that word conceptual, what it means is relating to a concept. And what is a concept? Well, I'm using it in a very broad and very simple sense, and that is it's an idea. And that idea, or any idea, I should say, has a name. Now, for the sake of discussion, just to get us started, I'm just going to use the names Concept 1, Concept 2, Concept 3, and so on. But we know that rather complex concepts like homeostasis have a name, homeostasis. That's the name of the concept. Very simple concepts such as sodium, that is an idea. It has a name, and there are things we can learn about the concept of sodium, what it is, and various other things about it. So yes, concepts have names, and that's going to be important in our understanding of how to use this technique of running concept lists. Another thing that I want to mention is remember that concepts can be either simple or complex. So I just mentioned that homeostasis is a complex concept. Sodium, that's a rather simple concept. And even objects that have a name, well, there's also a concept behind them. I mean, we can go to the very basics of experimentation about what learning is, and we can understand that animals, my dog has a concept of a ball. As a matter of fact, my dog has the capacity to distinguish between his favorite ball and some other random ball, like the ball that the cat likes to play with. That's not his favorite, but that's the cat's favorite. And so each of them has a concept of that particular ball, and that's in their brain, and it's part of their entire conceptual framework of where that ball is, how that ball acts, how that ball interacts with different surfaces. Each of those surfaces is a concept. And I don't know if animals have a name for it, but we have a name for it. Ball, that's a name. Ball bouncing around, that's a little bit more complex kind of concept. Bouncing, a bouncing ball. So concepts need not be overarching broad concepts. Now, a lot of times when we talk about core concepts in anatomy and physiology, we think about those large, complex, overarching things like acid-base balance or homeostasis or the flow of things down a gradient and so on. And those are all important, useful core concepts, but the concept of sodium, the concept of oxygen, the concept of carbon dioxide, those are concepts too. They're subsets of those larger concepts, and they're part of this whole conceptual framework that we're building of large concepts, little concepts, and how they relate to one another. Now, framework is an important aspect of this as well, because as I just mentioned, we want to put those together in relationships. So when we learn a new concept, about the only way we can do that effectively is to fit it somewhere in the existing web or framework of ideas that we already have, our conceptual framework. Because if we don't do that, then we're not going to know where to find them again. So what good does it do? Is it just throw it in there like throwing facts in a bucket? How are you ever going to find those facts again? And what good are they going to do you? So we need to put them in a framework of relationships. And what you're seeing here is what some people will call a mind map or a concept map. In this technique of using running concept lists, I should say, is related to concept mapping or mind mapping, but they're not exactly the same thing. And we'll get to what the relationship is and how they fit together a little bit later in this presentation. But what I want to do before we do that is, set the groundwork a little bit more and underscore the fact that we as A&P teachers already have great difficulty in having buckets and buckets of facts and concepts and so on that we need our students to learn. And that's a challenge. There are a lot of ideas in A&P, and it's really daunting, especially for beginning students who probably have never faced so many things to learn in so short a time. But that's not our only challenge. The even tougher challenge is to not only learn all of those things, but to construct a framework around them so that they're useful to us. What good is it to our students if they learn a set of unrelated concepts? Well, we all know the answer to that. It does them no good. No good at all. What they need to be able to do is put it into a framework. So how do we help them do that? Just telling them, oh, put it in a framework. Make connections. Tell them, hey, yep, make connections. Next day, make connections. What good does that do if they don't really know how to go about making those connections? Or even if they have some idea of making connections, how do we make that more efficient? How do we give them techniques that are going to make that work better than it otherwise would, because they're in this challenging situation of being in an A&P course? So that's where running concept lists comes in. So we've set the groundwork of why they're useful, what concepts are, at least for the sake of this discussion. And so let's take a look at this technique, which is basically just a list of terms. And remember, terms are the names of concepts. So it's not just the term itself, but the idea behind those terms. So there is a level of understanding beyond just the rote memorization of a definition or the definition of a term. And then, of course, the other thing about these lists is they're not just a list of terms that represent concepts, but they're a list of terms that are related to one another. So now you can see a little glimpse of how this technique is going to help students build their overall conceptual framework, because they're constructing a list of terms that they see as related. So it gives them a concrete thing to do, a concrete strategy, a step they can take along the way of forming their larger conceptual framework. So here's an example of a concept list for sodium. Now, the concept of sodium is related to many other things. These are characteristics of sodium. These are everything they're learning, all these other related ideas, that is, concepts that they might be learning in a course that relate to sodium. And we know sodium comes up many, many times in any story of the human body. And at first they learn, it's a positive ion. They learn what an ion is. They might have a list somewhere else that's their ion list, and they have all kinds of ideas related to what an ion is, and that they can be negative and positive and how that gets to be. They know that sodium is a component of table salt, which otherwise is known as sodium chloride, and sodium potassium pumps, and cells hate sodium because they're always pumping sodium out. That's just a little phrase I give my students to help them remember which way sodium is going to move and where in the body you would find sodium. You find it inside cells, outside of cells, not inside cells. And that could be explained by, this sort of made up idea, this analogy that cells hate sodium. So there's a few things on this list. And of course, there are many other things about sodium that a student can continue to add to that list. And we'll swing back around to that idea in just a moment. But just to emphasize again what these running concept lists are, I want to emphasize that they're cumulative lists. So we don't just, start with a blank page and then list everything we know about a topic. Well, we do at that point, but we know that at any point in the A&P course, it's not going to be a complete list, because there's probably other things to learn about that concept, just as the one we looked at a moment ago, and that is sodium. So we accumulate more terms and concepts that are related to the one that's the heading concept of that list, the main idea of that list. And so as we add to each list new ideas as they come up in the course, what we're doing is forming a running concept list. And I use the term running in a couple of different ways, and they both apply here. One is that you actually run that list. It's an active process, in a sense, that you start with a blank page, you put the name of a concept at the top, you write down one or two things, but then you hold on to it and you keep that in the back of your mind that you have this sodium list, for example, and you're going to run that list, meaning that every time sodium comes up, it's going to ring a little bell in your brain, say, oh, I have a concept list there. And so you're going to go to that list and add to it. So you're running the list. And so that list then becomes a running list. So we can use running in the sense of an adjective to describe, well, what kind of list is it? Well, it's a list that's not complete yet. There's always room for more information to add to that list. Even after the course is over, they're going to be learning more things about sodium, or things are going to come together for them, and they're going to realize that the thing that you were talking about, or the textbook was talking about, or the thing they did in their lab class, it's going to suddenly dawn on them by having another experience somewhere along the line. They're going to come back to that concept and say, oh, now I get it. Here's another aspect that I should have realized earlier, but I didn't. Or maybe they won't realize they should have understood it earlier, and that's okay too, because it's a running list and they can always add to it as things dawn on them. And I will tell you, as an A&P instructor, this happens to me all the time. I've been doing it for 3 decades, longer than 3 decades. And there are still times when I'm talking about some concept that I've talked about with students, and all of a sudden things come together for me. And I don't know why sometimes. I mean, sometimes it's triggered by a question a student asks, or some other part of a discussion with students or with peers. But a lot of times it just like comes up to me out of the blue. Like, why didn't I think about this relationship before? But there it is. It all makes sense now. Well, not all of it, but that thing now makes more sense than it did before. And so I'm adding that to my conceptual framework at that point. Maybe I should have done that earlier, but I don't know. So yes, teaching for me is a continuous process. And if we can get our students to understand that this is a lifelong process, maybe by getting them to do these running concept lists, that is going to help them for a very, very long time and in many, many ways. So what are some examples of topics that could generate their own concept list? And here's just a few that I thought of off the top of my head, and I ran out of room, but this can go on and on and on and on. And so you'll notice that some of them are very small concepts, like sodium and calcium at the beginning, ATP, that shows up a bunch of times in the course, right? But you move further down and you get flow down gradients. That could be the flow down a concentration gradient. That could be movement down a pressure gradient, like the movement of air in the airway or blood through the circulatory system. Cell junctions, that's a pretty big overarching thing, and we could list the different kinds of cell junctions, and then every time they come up and how their functions impact the structure and function of the human body, we could add to that. But let's just take one of those concepts that I've listed there, and that is collagen. Now, collagen's a fairly simple idea, right? And there's some things about collagen that we can learn. We can learn how it's built. I just jotted down a few ideas to start off with here, that it's a structural protein. It's a fibrous protein. It's white in real life, but we usually use stains that cause it to look pink. And that's an important thing to know, because the students are going to be seeing these things in textbooks, lab manuals, reference books, and so on. And if they kind of get the idea that it's usually pink, although not always, but in many images it's going to be pink, then that's going to be helpful to them. They might want to know that. And we know some characteristics of it, strong and flexible. And sometimes I even go into the structure of the protein bundles that form these collagenous bundles in our tissues. And then as time goes on in the course, we're going to learn more and more things. So it's found in fibrous connective tissues. And you might want to list in your concept map the different kinds of tissues that it's found in. I didn't do that here just for the sake of space. But what you do when you get to that next topic and realize that collagen is coming up again and we're learning more about collagen, what that's forcing me to do is review my past learning. What do I already know about collagen? And then how do I build on that? What more have I just learned that goes on top of that as another layer of learning here? And so that is a very concrete way to get me to think about how I'm building my conceptual framework. I'm not just doing it naturally in the way that we all do with new information that we get. I'm actually using a technique to focus on how that's being done. So that is hopefully not only making it more efficient in my brain, but it's also giving me a technique I can continue to use, and then it becomes more natural. And I get better at that than I would have without this very sort of formalized kind of practice in running a concept list. And so then we get to the next section on the skin, and we add more about what we know about collagen. We see it again, and then we get to the skeletal system and we see it again there in many areas. And of course, I'm not listing everything complete here because there just isn't room. And so each time I do that, I'm reviewing past learning, I'm building upon my existing conceptual framework, and I'm doing it again. And then I come back later and I do it again, and I come back later and I do it again. So that gives me time in between visits to this college and concept list to forget some of it. And we know learning science tells us by experimentation that we kind of have to learn, or we have to forget something before we can truly learn it for the long term. So I learn it, I forget some of it, I come back to my concept list because I realize I've learned some more, and I review that and say, oh yeah, I forgot it's a structural protein. Oh yeah, that's right, it is white, sometimes even called white fibers. And so I review that after I've forgotten a little bit. So I'm practicing that, right? And I'm strengthening that by forgetting, spacing it out a little bit, doing a little bit of retrieval practice, getting it back out, and then adding a layer on. And then I come back and I add another layer on after I've reviewed my past learning. So how do we get started using running concept lists for our students? So coming from the teacher perspective, how do you come up with, well, what concepts are good for a concept list? Well, I think your own experience is going to inform you, quite a bit, probably enough. So you know what kinds of things come up again and again in the course. And once you start watching for them, then you realize that, wow, there are a lot of things that keep coming up. Things like sodium and chloride and potassium ions and all kinds of things keep coming up again and again. And even those overarching principles, such as membrane transport. Man, that comes up a lot, doesn't it? Signal transduction, that comes up all the time when we talk about signaling in the endocrine system and the nervous system, just all kinds of places. And of course, the endocrine system and nervous system, they show up in all kinds of places too. Another place to kind of spark this thinking and give you some ideas are the HAPS Learning Outcomes. So go to the HAPS website, and if you're a member, just go to the Learning Outcomes page, and that'll sort of get your mind thinking along those lines of what are the overarching principles that are considered to be the core ideas that we want our students to bring out of the A&P course. The American Physiological Society, APS, has all kinds of things related to core concepts, but one in particular is a book that you can get through their website on core concepts. And I highly recommend reading through that book. It has some great ideas. And they have, I think, a list of something like 15 core concepts that they've identified, but they're looking at the overarching ones. So when you dive deeper, you start to see the smaller concepts that relate to that. And that's going to get your wheels churning, right? Or it's going to get you diving into your own conceptual framework to see where the repetitions are. And you can even do a word search. If you use an outline in your course, or you have a digital version of your textbook or something like that, you can do a word search and see, well, what comes up very often. Or even just look at the index and see which terms in the index of a textbook have a lot of entries under them, meaning that you're hitting them in a lot of different places in the textbook. So there are many ways to kind of get the thought processes going and get you started on the road of, just for yourself as the teacher, thinking about how to build a concept list and what are good subjects for each concept list. Now, as a student, how do you get started with this, and how can we help our students start using a running concept list and start seeing the value in doing a running concept list? Well, the first thing is we tell them to start to watch for recurring terms. I do that at the very beginning of my course. I will, as soon as a term recurs for the second time, I'll say ATP. Now, we just talked about ATP in another context. Here it is again. This would be a good idea to start a concept list for ATP. Sodium comes up early, potassium comes up early, calcium comes up early. And I say, calcium, it's going to come up again and again and again and again. And that was like 4 again. So that's pretty high on my importance level scale. And that is that, yeah, we're going to see that again and again. So that kind of puts it in the student's head that they, maybe that'd be a good concept list. As a matter of fact, at the beginning, of course, I say that. Look, here's sodium again. It's going to come up again and again. I don't leave it there. I say, hey, I would have a sodium concept list. You're going to use that sodium concept list. If you don't have any other concept list at all, at least do a sodium one, because it's that important to remember. And it's that important to keep reviewing, so that because each time you're reviewing it, you're starting to see more and more connections of things, and it's going to be easier for you the next time you run into sodium after that. You're going to already have this little whole section of your conceptual framework already built up around sodium. And so I also tell them to listen for hints from the teacher, not just from me, but in any of their courses. I might occasionally say, hey, you need a concept list, or hey, let's add this to our ATP concept list. But, for other teachers might not even be aware of the idea or don't use the term running concept list. We do this just naturally as we explain things to each other. We'll say, hey, this is going to come up again. Hey, this is important. We're going to need this later. Those are all hints that, hey, maybe we need a concept list going on this particular topic or this particular concept. And there are many ways that students can do this in a physical sense, like how to organize these concept lists. I think a really good way is to use very large index cards, those like 4x6 cards or even larger. 3x5 cards work okay. And index cards do, some of them, especially like sodium and collagen, so when they tend to get filled up, the more information you put on there. But you can always staple another one and actually add pages, and it'll still fit into whatever box you're using to file your index cards. You can also use ring binder pages. That's good. A lot of students like to think and operate digitally, so you can use like Google Notes, OneNote, Evernote. There's all kinds of note kinds of software that you can use and then rearrange them. You can use things like Quizlet and so on, different flashcard software and platforms and so on, and organize your concept lists that way. But they're more than just your typical flashcard in that you're adding, and you're really making sort of your own wiki or your own encyclopedia when you do that. Now, I used to tell my students, many of whom used spiral notebooks a lot, but they kind of got away from it for a variety of reasons. But if you use a spiral notebook, I told them to do your class notes from the front, but you do your concept list from the back. So it's actually two notebooks in one. The problem with doing it that way is that you can't rearrange them in alphabetical order or any other kind of order that will help you find them again. So it adds a level of frustration that doesn't need to be there. So that's why I recommend the ones that are listed at the top of my list rather than a spiral notebook. Now, as I mentioned a moment ago, this becomes kind of a running reference source. And so that means that it's not only a student's own sort of encyclopedia in their own language and therefore more meaningful to them, it's also something that is living. That is, it's constantly being edited and added to and tweaked. And so when your students ask you for a study guide, you just tell them you already have a study guide. You have your concept list. It's a built-in study tool. And it's also a running learning process, meaning that they are doing learning when they do this. This is a way to sort of formalize their learning in a way that they can eventually just be doing this naturally. So it's like learning some kind of physical activity or so on, where maybe there are certain steps you take in order to learn how to kick a soccer ball in a certain direction. And before you know it, you're doing it without thinking. It's natural rather than thinking what steps you need to take. And it's the same thing here. You're giving them a framework of steps to take, but then eventually that just becomes part of the way their mind works, and their mind starts working better because of it. And as I mentioned a moment ago also, you're doing spaced retrieval practice when you're using these, because every time you come back to your concept list, there's been some space and time. And so you've done a little forgetting, and we know that that spacing is much better than grouped practice or block practice. And we also know that just the practice itself is important to learning. And it builds that habit of looking for connections. So not only is it giving us a formal way to organize the thoughts as they come in, it builds the habit, it strengthens that habit of actually going out and looking for things to add to the list, looking for ways that things connect. And that's important. That's a higher level thinking skill that is really hard to teach, but here's a technique that we can use along with other techniques to help us build that. And I mentioned a little while ago, actually at the beginning of this presentation, that I'd swing back around to concept maps. And so here we are, also called mind maps. And concept maps are very good for teaching and learning. But there's an initial step that you have to do before you can build a concept map. And that is you have to start to sort of brainstorm and just write down some things that are related to one another. You need to do that before you can start to arrange them in any kind of order. So when you build a concept map, one way to do that literally is to take your concept list and then just take all of those individual things, maybe write them down on different sticky notes or different little index cards, and you write them down separately. Now you can make a concept map. Now you can kind of spread them around on the table and start to move them around in terms of how they relate to one another. So now you're strengthening that conceptual framework even more. You're organizing that conceptual framework even more. So this isn't something to do instead of concept mapping. This is something to do that prepares you for concept mapping and makes that more efficient. It makes it sort of easier to get to, because a lot of times when you tell a student to do a concept map, they don't even know where to start. Even if you give them the main idea, they don't know where to start with that. But if they have a running concept list already started, or maybe even completed up to that point in your course, that's an easy place to get started. And again, once they're doing it using these formal mechanisms, once they start using running concept lists, then use those to build concept maps, now they're starting to think in these ways. And that's going to deepen their thought processes, and it's going to bring them to a higher level of critical thinking. And of course, that leads to lifelong learning, because we want our students to be successful in A&P, not just for its own sake, although I think there's some value in that, because it gets your brain thinking in different ways, just like, any of the liberal arts and so on, any of the humanities, math, and different things, different topics. Just learning any topic is going to make your brain work better than it otherwise would have in many different ways. But in A&P, we're preparing students usually for a health career. And so they're going to need to take that content out of our course and into the next course and eventually into their career. And we want them to not just take a bucket of facts or a bucket of concepts, as I was talking about earlier. We want them to take a conceptual framework. But we also want them to bring the techniques, the skills inside our brain with them to apply to lifelong learning, because when they get to that next course, they're going to be adding things to those concept lists. That is, they're going to be adding things to their conceptual framework. Constructivism tells us that is what happens when we do learning in those later courses. And that's going to keep building from course to course to course to their early clinical experiences, like residencies and clinicals and things like that, and then start to build throughout their career. And I don't know about you folks, and I don't know about your students, I don't even know about some of my students, but I know for me, that has not stopped. I'm continuing to learn things about A&P, about the content of A&P. And I mentioned that a little bit earlier, but don't we all do that? Don't we all add to that? And so this gets our brain going. And even if we lose the training wheels or set aside the training wheels of the actual cards or pages that we're using as running concept lists, we've already sort of built that into the way our brain works. So implementing this in a practical way in your course, how can you do that? Well, one is you can refer students to various resources that teach them how to do concept lists. And I have that if you go to lyondon.com and look at the study tips and tools, or you go to theapstudent.org, where I have a blog. In both places, just search for Concept List, and I have videos and all kinds of other resources that get students started. So you can just refer your students as a class or an individual student who's asking you for study techniques. You can just refer them to those sources and leave it at that. Or you can actually show them how to use concept lists and maybe draw one out on the board or something, or explain it at least verbally. Another thing that you can do is actually assign it to them and tell them, hey, I want the start of a concept list on sodium. I want that, at the end of this module. Or I want, 3 concept maps or 10 concept maps or whatever. Or maybe you're grading by portfolio, and that can be part of the portfolio is I want a significant number of concept maps in here. I want to see you using concept maps. So there are a lot of different ways, a lot of different directions you can go in as far as that goes. And you can even make it a class activity. I mean, I talk about it in my class, and I sometimes say, okay, let's stop. Let's get out your concept maps and let's do it, just to see if anybody has a concept map they can pull out, because I don't assign this and I don't make them do it. I just offer this as a technique and encourage it. But you might make it a class activity where maybe the last few minutes of every class, that's what you do as kind of a wrap up, is kind of a way to gel what happened in that course and say, okay, let's take out your set of concept maps here, and what are some concepts that have come up again in what we discussed and what we did in our case study today and what I lectured about, or whatever it is you did in class. You can do this in lab too. Say, what came up today that fits with other things that we've learned before? What concept maps do you already have? What concept maps do you think we should start here? And you can do that as a whole class activity, or you can do it in small groups to kind of get them talking with one another and collaborating. Or you could just have them do that silently as individuals before they leave the class. A lot of different directions to go in with that as well. So I hope this has given you some ideas about how we can better support our students in developing those higher order thinking skills and making the connections that they need to be able to make in order to truly learn anatomy and physiology in a way that is useful and meaningful to our students. I'll see you down the road.